Today, we're diving under the hood of the Internet to understand the domain name system, or DNS. By the end of this script, you will know the exact, step-by-step journey your request takes to find any website you type into your browser. The Internet is simply what we call an interconnected network, a vast web of devices talking to each other. But how do you, as a human, ask your computer to find something on this massive network? This is where the DNS mechanism, the domain name system, comes in. You, the human, prefer easy names like myspace.com. But computers only speak in numbers, known as IP addresses. DNS is the Internet's phone book, translating those memorable names into the specific, computer-readable IP addresses. Now, let's trace the journey your computer takes every time you hit enter. This is the DNS lookup path. First, your computer checks its local DNS cache. Think of this as your brain's short-term memory. Have you visited this website in the last few minutes? If the address is already stored here, the connection is instant and the journey stops. If not in the cache, it checks the host file. This is like a tiny, physical notepad where you can manually assign a domain name to an IP address. It's often used by system administrators or for testing, but rarely by a normal user. Next, the request goes to your ISP, your Internet Service Provider. This is the first stop outside your home network. Your ISP, like Comcast or AT&T, maintains its own massive DNS servers, often organized in tiers, that handle millions of requests every day. Finally, if the ISP doesn't know the answer, the request is sent to a root server. These are 13 critical, global servers that hold the top-level directory for all domain names. They don't know the full address, but they know which server is responsible for the top-level domain, like .com, .org, or .net. This is the true global directory. The entire journey happens in milliseconds. The root server points to the .com server, which points to the website's specific server, which finally sends the IP address back to your browser. You get to the website without ever seeing the numbers. If you ever want to see this process in action, you can use simple DNS commands. The command IP protocol configuration /display DNS lets you peek into that short-term memory, your local DNS cache, to see every recent website your computer has looked up. And if you want to clear that memory to make sure you get the freshest data, you use IP protocol configuration /flush DNS. This clears out the old records and forces your computer to retrace the full path the next time you visit a site. But DNS does more than just find a website. The domain entry holds many different instructions for a domain in the form of DNS record types. While the basic name-to-number mapping is handled by the A record, other services need special instructions. For example, MX records, or mail exchange records, tell the Internet exactly which server handles email for that domain, ensuring your message reaches the right company mailbox. You also have the name, canonical name, which is essentially an alias that points one domain name to another. And critically for security, the TXT record. These are plain text notes used for domain verification and to hold standards like SPF and MARC, helping to prove your domain is trustworthy and not being used for spam or phishing. To recap, the Internet is an interconnected network. DNS acts as its phone book, translating human-readable names into computer IP addresses. The lookup follows 4 steps: local DNS cache, the host file, your ISP servers, and finally, the global root servers. And records like A, MX, and TXT define specific services, like email and security verification, for that domain. This quick, behind-the-scenes process is what makes the Internet work.